Welcome, everyone. My name is Derek Martin. I'm a Principal Program Manager in the Microsoft Patterns and Practices team.
And I'm John Patrick Dandison. I am a Principal Program Manager in the Identity Developer Experience and Advocacy team.
And we're here to talk to you today about building well-architected secure applications with Azure. With the Microsoft Azure well-architected framework, you can build workloads with confidence based on proven deep technical guidance that is actionable and simple to use. And it helps you identify areas of improvements and where to focus your workload optimization efforts. But the framework doesn't stand on its own. It's at the center of this ecosystem of best practices, documentation, assessments, reference architectures, and design principles. All of this is supported and amplified by our partners and services team that allow us to offer you guidance to assist you in improving your workload quality. For example, we have the well-architected framework, which enables you to achieve your business objectives, operationalizing how to design, build, and optimize your cloud solutions. We have the well-architected review, which provides evaluations of workloads to provide gap analysis and identify areas of where you can focus your optimization efforts. We have our reference architectures, which helps you build and deploy any workload to scale and meet your business needs. Our design principles, which are based on proven practices and design patterns from successful customers and partner deployments. And then our partner and service offers, which support you and help you build your cloud solutions. Now that you have some idea about the foundational concepts around the Microsoft Azure well-architected framework, we need to learn how we go about collaborating to make our customers well-architected. And for that, we focus on security. JP, as you know, in the security pillar, we're working to build and manage proactively secured workloads. That means it has to be built on a secure foundation. It has to proactively stay secure with native controls, and it has to allow us to detect and respond to emerging threats. Inside that security pillar, identity plays a really significant role. So tell me what your thoughts are on identity and how we can help customers secure their workloads.
Sure. Identity is the root of everything. It's where it all starts. If I don't know who you are, or if we don't know what kind of service you're accessing, it's very difficult for us to effectively secure. It's really difficult for us to effectively audit who's doing what inside of your cloud subscriptions. And so as we're building these new applications, identity is the most foundational part that everything else builds on top of.
JP, why is identity the key to platform trust?
So when we're building resources and deploying applications, it's really, really imperative that we know who these users are. It's very important that we know who the users are that are accessing the services, but then also what are the identities of the applications that are then accessing your Azure services. So, for example, I may have a web app that needs to talk to a SQL database, which is a pretty common scenario. Not only do I need to know who the users are so that they only see their data, but then I also need to make sure I know what service is calling into my SQL database so that we make sure that that data doesn't leak and doesn't get exfiltrated away from our Azure subscriptions or from our business, but then also so that we can see over time who's been accessing these services and how have those services been accessed so that we can respond in the unfortunate event of data exfiltration.
Yeah, that's a great point. A lot of the customers that I've worked with from the Patterns and Practices team really struggle with understanding the role that identity plays and how it can be applied to a security foundation, not just how to log in and all of those things. And certainly we need to talk about those things, but how we use that data that gets generated from the platform itself to help maintain a secure ecosystem. So let's talk a little bit about building secure apps within Azure. I know that we have a lot of different choices when it comes to platform selection. We've got Azure Active Directory, we've got B2C, we've got B2B, we've got OAuth, we've got SAML, we've got WSFed. The list goes on quite a while. But tell us a little bit about the different criteria that you would go through regarding platform selection.
Sure, yeah. So if you're into acronyms, we have plenty for you. When we start with the Azure Active Directory, which is sort of the main offering. So if you're using Office 365, if you're using Azure, you're signing in with Azure Active Directory whenever you use one of those resources to sign into the portal or to interact with those services. And it's fantastic for workplace identity, for knowing who you are at work and for giving you access to your email inbox and SharePoint sites and OneDrive. It's great for that. So we think of it as kind of an extension of your on-premises identities, especially in many cases with large enterprises. Those on-premises identities that we've had for a really long time end up in Azure Active Directory as sort of an extension of that on-prem. For workplace identity, that's the big place to start. And because of that, you are required to have an Azure Active Directory account to use Azure, to use Office 365. So for all of our cloud services, Azure AD is sort of the main place that you need to be. The requirements of customers and the requirements of the kinds of applications that they need to build don't necessarily always fall into these really nice, clean buckets of, well, you work for company ABC, and thus you need access to resource ABC. And so because of that, we've opened up and added more features. So the first feature is Azure AD B2B. And B2B is not necessarily a completely separate offering as much as it is a feature of Azure AD. B2B's primary focus is on collaboration. So if you and I were working together and say I worked at Microsoft and you worked for Contoso, and I was hiring you to say, work with me on event planning to do an event, something like a build. If you didn't work for me, but you work for another company, I still need to give you access to resources within my company for us to be able to work together. They might be documents, they might be applications in Azure, they might be team chats and team files that we're doing in Microsoft Teams. And in order to give you that access, I have to be able to get you into my directory and to be able to manipulate your user account in a way that lets me secure my business data. And so that's what B2B gives us. So if you're building applications for you to do business, B2B is a great way to pull in those external users who are doing work with you in order to give them access and control their access to your business data. The third big chunk of identity services that we have is something called Azure AD B2C. And Azure AD B2C is all about building applications that are going to go out externally. So it's all about the startup that's building their next big Pinterest or Instagram V2, or building their next big app for the internet, right? Where they need to bring in individuals. They need to sign users in with their Facebook accounts or their Twitter accounts or their Google accounts. B2C is extremely flexible in that we can take in all sorts of different identity providers, and then we can use B2C as a platform to centralize, and then all of our applications downstream will trust B2C. So if you're building an app with 10 people to start, but you need to scale to 10 million, B2C will be there for you to make sure you sign in your users correctly and have confidence that that platform is gonna keep you out of the news because of any sort of security problem.
That brings me to one of our first questions, and it's really centered around identity and access management. How do I know who my users are?
So there are four big A's in identity and access management. We've got authentication, authorization, administration, and auditing. And the first two are really important for developers. All four of them are very important for everybody, but the first two are really important to developers because that's where they're going to have to spend most of their time in implementation. Authentication is all about the process of knowing who you are and knowing who you are with a high enough confidence that I can show you data that is yours. I can show you your bank account. I can show you your documents that you've worked on. And that authentication process is the key, really the first step in building secure applications. How do I securely know who my users are when they come into my application so that I can then show them the data that they need to see and not other people's data? The majority of modern identity systems rely on things like OpenID Connect and OAuth 2 for signing users in and for granting access to other resources. OpenID Connect was an add-on to OAuth 2 to add authentication to that OAuth 2 authorization pipeline. What we got with OpenID Connect was the ability to both authenticate a user securely to know who that user was from a trusted system like Azure AD or Azure AD B2C, and then also be authorized access to other resources as them. And that brings us to our second A, which is authorization. And with authorization, it's really a way to say, I know who you are. Now you have access to something, and I would like access to that. Think of when you install a new app on your phone and it says this app would like to access your contacts, or when you add a new app to your Facebook account or to your Spotify account and it says, I would like to access your Facebook contacts or your Facebook friends list. That is a typical OAuth 2 authorization prompt. And what we're doing is instead of asking a user for their credentials and saying, hello, user, please give me your credentials, which gives you access to everything.
Yeah, don't do
Instead,
that.
we're saying, please give me access to a subset of the data that you have.
Right.
So you can think our Microsoft accounts, both private and work, your Google account or your Twitter account. These are pretty privileged accounts because they cover a broad swath of our lives. My personal Microsoft account has Azure subscriptions and Office 365 and Xbox and all sorts of different things associated with me. If I want to see my calendar on my cell phone, do I really want to give my password to, a random calendar app from the App Store? And I think that's one of the big keys is being very specific and very deliberate about not only how do we sign our users in and know who they are, but then once we know who our users are, how do we let them control what applications and what services have access to the data that we're holding? And then what applications and services do we need to get data for as developers in order to enrich their experiences?
When we talk about our Azure App Services, the services themselves, there's another notion of authentication and authorization that doesn't really have anything to do with the end users. For instance, how do I access the resources that make my app work? And how is that different from my individual user accounts?
So anyone who's had to build software in the last 20 years on premises, for example, there was always this sort of notion or this vague idea of something called a service account. And sometimes it was as simple as a user account that was called service. The first name was service. And as things matured, we ended up with accounts that were things like managed service accounts, where things like Active Directory would manage those for you. In cloud, it's really not that different. In cloud, we still have this concept of a headless or a non-user account or principal account, some kind of an account that can be granted permission to do different tasks or granted permission to specific resources, but doesn't necessarily have a specific user sitting in front of it. And so in Azure AD, we call those service principals. And service principals are typically fairly privileged. And the reason why a service principal is so privileged is because typically they don't have a user account associated with them at all. Right. So you can think, when I sign into an application, say I sign into my mailbox, it's looking at my email. It's looking at John's email.
Right.
If I have an application that wants to send an email on my behalf, or if I have an application that needs to send out monitoring emails to my users, I need to be able to access Exchange or access my mail service, and not as an individual user. I wouldn't want a notification to go out to one of my users from my email address. I want to go out from some sort of an unmonitored reply, no reply type of an address. But in order to make that service connection, somebody needs to sign in, or something needs to sign in. And that thing that needs to sign in and be granted permission in Azure AD is called a service principal. And you can think of it as kind of like a service account in the sense that the typical uses of it are to be in this kind of headless model where we don't have a user. And because we don't have that user, we have to be very careful with these service principals because they tend to be quite privileged.
All right. So I get what a service principal is. Tell me a little bit about what is a managed identity. That doesn't make any sense to me.
Managed identity is one of my favorite parts of Azure AD.
Of course it would be.
It also solves one of those problems that you don't know until you have the problem. And then you realize, wow, managed identity is amazing because it solves these problems that I didn't know I had until I started going down this route. The big thing about a service principal is a service principal, in order to authenticate, needs to have some kind of a credential. We support two different kinds of credentials. You can have a string, which is essentially a password, or you can use a certificate, which is what we would advise for production deployments. But because that service principal needs to have some kind of a credential, it now means me as a developer or me as the ops person who's responsible for deploying this app, now I've got a new credential that I have to deal with. I have to figure out a way to save it securely somewhere in my infrastructure or in app settings. Key Vault is one of them. Key Vault's a good one. But in order to access Key Vault, I still need some kind of a principal that can connect to Key Vault. So we end up in a place where we keep kicking the can further and further down the road. And so we need a way to deal with those secrets and to deal with those certificates in a manner that's a little bit more sustainable. So you can imagine I've created a service principal, and that service principal has a credential. That credential was created today on March 17th at 6:42 p.m. Well, that means that in 12 months, at the exact same time, that credential is going to expire. And it means that the one that I create tomorrow is going to expire at the same time, but a day later. And the one I create 2 weeks from now. And so you see the issue of, well, how do we maintain this key rotation? Because we need to rotate these keys. In larger enterprises, that can be easier with certificates, because typically certificates that come from a CA have a little bit better hygiene in terms of knowing when they're going to expire and being able to manage their renewal. But at any rate, if you've got even a dozen applications, managing all those secrets and all those credentials can be a real hassle.
So is this where managed identity comes in to make life easier?
This is where managed identity comes in. So managed identity is a way for us to give Azure resources a service principal identity that represents themselves. So an Azure App Service or an Azure VM, these resources can be granted permission to other resources as themselves, and the credentials for them are managed by the platform. So instead of you, the developer, being responsible for storing a certificate or storing a secret securely somewhere, like a connection string, for example, instead of you being responsible for that, we manage that for you. So we manage the key rotation, and what you do is from your applications, you either use a library or you call a special endpoint, a special HTTP endpoint that's available on all these resources. And that special HTTP endpoint gives you a token, an access token, to go and access the service that you need. So a great example of this would be, I need to access a SQL database, or I need to access Azure Blob Storage from my application. If we look at SQL, well, we've got SQL authentication. So we've got a username and a password. Well, where are we going to put it? Maybe we put it in an app settings file somewhere. Maybe we put it in Azure config, in our app service config. Maybe we put it in Key Vault. But then we need some way to call into Key Vault. And now we end up with yet another credential that we have to manage somewhere. But instead, because these managed identities are Azure AD service principals under the hood, now we can grant that managed identity access to resources, just like if it was a normal service principal that we had generated manually.
Okay.
And now when our applications need to access those services, they call the special magic endpoint, or they use the library, and then they get a token to go call that service. And now you as a developer are completely out of the game when it comes to managing those credentials.
So credential management being what it is, managed identity being better than that, surely I'm still going to have secrets that have to be dealt with from dev to test to stage to int to UAT to prod, or whatever flavor of the month you've got for your CI/CD pipeline. The well-architected framework talks a lot about secret management and how you go about dealing with secrets and identity across your developer workflow. Can you elaborate a little bit on what that means and how those things work?
Sure. So we store secrets. We have a service called Azure Key Vault, and Azure Key Vault is essentially a secret store. You can think of it as a super secure, slow database. At the end of the day, that's what it is. You don't use it as a database, use it as a key value pair store. But it also stores certificates. So secrets of any kind can be stored in Key Vault and then accessed via API. And there's an entire ecosystem of tooling, both in terms of libraries that have been written in end user tools or developer tools, things like Azure CLI and Terraform and all the different tools that a developer would use, or an ops person over the course of their workflow, that all have some kind of support for Key Vault. For example, in .NET, there's an ASP.NET Core library specifically for pulling your configuration settings from Key Vault. Instead of you having to write that code yourself to go and call into Key Vault and pull out all of your configuration settings, instead, that package will do it for you. It does all the work for you, and it ends up in the same configuration pipeline as a JSON file or environment variables or anything else. And so because of that ecosystem, we really end up in a place where we have lots of tools that meet you where you are as a developer, that lets you store these secrets and version these secrets and manage access to those secrets without necessarily having to do a whole lot of the work yourself. Everything that's in Key Vault is managed via policy, and those policies are what dictate what principals are allowed to do certain operations on the secrets within that key vault. Let's say we have an application that needs to go from dev to test into production. The dev key vault may have certain keys that are available or accessible to me as a developer, but the roles that are allowed to see the production secrets may only be for our production teams, only for the teams that are going to handle and touch and manage production, which as a developer takes a lot of the liability off of my plate. I don't even have access to production secrets, and I don't want access to production secrets.
It's as simple as I could drop in a Nugget package or an NPM package up and going. We let the security guys deal with the role-based access control and the policies, and life just gets a whole lot easier.
That's right. You don't have to worry about any changes in your code. The only thing that you need is an identity that can connect to Key Vault, which could be a managed identity, which is an extremely common pattern. The managed identity that is accessing the Key Vault has permissions to do things like, say, read a secret or list the secrets that are available to get the ones that they need. And your code doesn't change. Your code still says, hey, Key Vault, please give me these secrets. And then Key Vault gives you the secret based on who you are and based on your access level.
JP, that's fantastic. So to get started, we're going to assess our workloads with the Azure Well-Architected Review. Next, we're going to go in and review your decisions. What pillars are you trying to assess? Has your workload been deployed? If it has, you can optimize your Azure resources with the Azure Advisor recommendations, and you can start your workload assessment by clicking on the link. That final step with reviewing your recommendations and optimizing your workloads really breaks down into three pieces. First, you complete the workload assessment with the Azure Well-Architected Review. Second, you review all the actionable recommendations. And third, use those recommendations to optimize your workload and make them more secure, reliable, performant, and cost-effective. Thank you all so much for joining us today. We hope you learned a lot about the Well-Architected Framework's security pillar. JP, really enjoyed chatting with you.
And you as well. Thank you so much for having me.
Take care, everyone.